Okay, so in this video here, we're going to be talking about how to find the area under the curve. And before we start this video, there's one thing you have to know how to do here, and that is how to find the antiderivative. And that's what you're looking at in red right here. So that is how we find the antiderivative of a function. Now, what you're looking at in purple, this is the definite integral from a to b. And I'm going to show you how to use this in this video. But again, you do have to know how to take the antiderivative here, and in particular, how to use the power rule, because all of the problems in this video here are going to be using the power rule when we do the antiderivative. So let's go ahead and take a look at our first example here. So here's our first example, and you can see that we're dealing with a quadratic, and they want to know the area under the curve going from 1 to 3. So again, this is in respect to the x. You can see I have 1 here and 3 here. They want to know this area here. So the first thing that we have to do is we have to set up our integral. So we're going to say here area is equal to, and then again, we're going from a to b. So the definite integral from a to b. Now your a here is going to be 1, your b is going to be 3. So you always go from lower to upper limit. So when I write this out, it's going to look the following way. I'm going to write my integral, and I know that in this problem here, I'm going from 1 to 3. So I'm going to say 1 to 3, and then I have to take the antiderivative of f of x. I'm going to say here f of x dx, okay, which we know is going to be equal to x to the third power all over 3, okay? And again, I'm just using the power rule here. And then from here, we want to go ahead and put on the region in which we're solving for, and that's going to be from 1 to 3. So I'm going to say here 1 to 3, and then we're going to go for it. So first, you want to do the upper limit. So I'm going to say here area is equal to, doing the upper limit first, I'm going to use 3. I'm going to say here 3 to the power of 3 all over 3. Again, just plugging that into x. And then we put subtraction, we minus, and then we do the lower limit. So we're going to use 1 here. So in parentheses, we're going to say here 1 to the third power, and then all over 3. And then we're simply just going to do it out. So 3 to the third power is going to give you 27. So I get 27 all over 3. And then minus, well, 1 cubed is going to give you 1. And then over 3. So I get 1 over 3 here. And this is nice because they have the same common denominator. So I'm just going to subtract it. I get area is going to be equal to 26 over 3. So 26 over 3. And as a decimal, that's going to be 8.6 repeating. But I'm going to go ahead and leave it like this here. And there it is. So that's going to be the area under the curve. Let's go ahead and try another example. So here's my next example. This time I'm dealing with a cubic, but we're going to do the same thing here. So I'm going to say area is equal to, and then I'm going to do the definite integral from a to b. In our case here, it's going to be 2 to 4. So doing the definite integral from a to b, that's going to be 2 to 4. And then again, I'm going to take the antiderivative of f of x. I'm going to say f of x, and then dx, which is going to be equal to, applying the power rule here, which is going to be x to the fourth power all over 4. And then again, we're going to be going from 2 to 4. So I'm going to go ahead and put that on, 2 to 4, right? And then again, we're just going to plug in and subtract. So area is going to be equal to, well, I'm going to plug in 4 here. So 4, and then to the fourth power all over 4, minus, now I'm going to do my lower limit. I'm going to plug in a 2 here into x, and then to the fourth power all over 4. So what do we end up getting here? Area is going to be equal to 4 to the fourth power will give you 256 all over 4, minus 2 to the fourth power, that will give you 16. So 16 all over 4. And then I just have to do 256 minus 16, and that will give me 240. So area is equal to 240 all over 4. And that will actually divide evenly. So 240 divided by 4, that will give me 60. So that's going to be my final answer here, 60, right? And there we go, right? All right, let's go ahead and try 2 more examples. Okay, so here's my next example. This time it's linear, right? I'm dealing with a line. So I'm going to go ahead and set up my definite integral. I'm going to say area is equal to the definite integral of 0 to 5. And then again, I'm doing f of x dx. Got to take the antiderivative here. That will give me x squared all over 2, and then plus 3x. And then from here, I'm going to go ahead and put on my values. I'm going from 0 to 5, right? 0 to 5, right? So we're going to go ahead and plug that in. So area is equal to, plugging into x, we're going to do the upper limit first. So I'm going to say here 5 to the second power. So I'm going to say 5 to the second power all over 2, just plugging into x, right? And then plus 3 times 5, okay? And then we have minus, now doing the lower limit. Now, this one here, think about it, I'm plugging in a 0, okay? So if I plug in a 0 into x here and also here, the whole thing is just going to be 0, right? So I'm not even going to bother writing this out. What I'm going to do, I'm just going to put 0 here because that's what I'm going to end up getting. So I only really have to do this part right here. So when I do that, I get the following. Area is equal to 25 all over 2 plus 15. And from here, you could plug that into your calculator, or we could go ahead and combine these. So this 15 is really over 1. So I have to get a common denominator here, meaning I'm going to have to multiply this fraction both bottom and top by 2. When I do that, I get 25 plus 30 all over 2. So when I combine my numerator there, I get 55. So my area is going to be 55 all over 2. And there it is. Okay. All right, let's try one more example. Okay, so here's my last example. You can see that I'm dealing with another quadratic here. So again, we want to get the area under the curve going from 4 to 6. So I'm going to say area is equal to the definite integral of, and again, my lower limit is 4, upper limit is 6. And then I'm going to go ahead and do f of x and then dx. So taking the antiderivative here, that's going to give me x to the third power all over 3. This will give me plus, now remember, it's going to end up being 10x squared all over 2. So that will end up being 5x squared, so I can reduce it. And again, it is minus here, so I should actually put minus, right? Minus, and I'm going to put 5x squared. Again, when you apply the power rule there, it is going to be 10x to second power all over 2. But again, 10 and 2 will make 5, hence we're putting 5 here, right? And then we're going to get plus 27x, and there it is. So again, putting all my limits here, my lower limit is going to be 4, my upper limit is going to be 6, and then plugging it in, we get the following. Area is equal to, now this one's going to be a bit longer. So doing the first part here, we're going to do the upper limit. So I'm going to be plugging 6 into x here. So here we go. I'm going to get 6 cubed all over 3 minus 5 times 6 to the second power, and then plus 27 times 6, and there we go. There's the first part. Then we have minus, and we're going to do the same thing, this time for the lower limit, in this case here 4. So I'm going to plug in here 4 to the third power all over 3, and then I have minus 5 times 4 all to the second power, and then finally plus 27 times 4, and there we go. That part is done. So you're going to want to use your calculator here. You're going to go ahead and get this part here, then you'll get this part, and then you will subtract them. All right. So let's go ahead and get the first part here. So when you plug the first part into your calculator, you should get 54. So I'm going to go ahead and put 54 here. Right. And then we're going to plug the second part into our calculator. And when you do that, you get 49.3 repeating. So I'm just going to go ahead and put here minus 49.3 repeating. And again, you could get the fractional values here, but to keep it simple, I'll just go ahead and write it as a decimal. And then from here, you're simply going to subtract these two numbers. And so when you do that, you get 4.6 repeating. So I'm going to go ahead and put here area is equal to 4.6, and that is repeating. And there it is. So that's how you can get the area under the curve. Again, it's pretty straightforward. You do have to know how to take the antiderivative. And in this video here, we use the power rule for all of these examples. But again, we did introduce something called the definite integral, and that's pretty simple to use. You're just going to go ahead and put on your limits depending on where they want that curve to be bound. And then you'll go ahead and take the antiderivative. And then from there, you simply plug it in and subtract, right? So that's it. I hope that you found the video helpful. I hope that you gained something from it. If this video did in fact help you, if you could just go ahead and give it a thumbs up, that'd be greatly appreciated. Also, make sure you subscribe. That way you get more math videos in the future. And I'll see you in the next one.